Hello everyone, welcome to my YouTube channel. This video is in continuation to the previous video which was made on trigonometry O-level past papers, and the reference year for this question is June 2016 paper 2 question number 9. Now in this question the conditions given is we have this wind turbine having the length of each blade as 30 meter, and the other conditions given here is the angle of elevation of A from B is 34, of A from B is 34, that means this complete angle is 34. Second angle given is the angle of elevation of C from B. So of C from B, in that case it has to be this angle, which is of 25 degrees, and the difference between the two angles, it would be 9 degrees, right? Another important thing or information we can obtain here is if this is 90 degree, 90 plus 25 would sum up to 115 and with 115 we can have this angle as 65 using the sum of triangle, and this angle would also be 115 being the supplement of 65. So to find, in the first part, to find AB being this side. Now AB is not a part of any complete right angle triangle. By complete triangle I mean any complete side given in the figure. We have this 30 units given, but it's just a part of it, not the complete perpendicular. So that means I have to draw a non-right angle triangle here, and a non-right angle triangle would be drawn in this manner, in which the points are A, C, this is 30 units, and this is a small angle of 9 degrees here, this being the point B. Now we have to find this side AB here. Now to find, and one more thing, we have this angle as well, which is of 115 degree. Now to find AB, AB, it's the side opposite to 115 degree. And the another pair of measurements given is 9 degree and opposite to 9 degrees 30. So whenever we are having one complete pair, a side and an angle, we always use a cosine rule. Now cosine rule can be applied here as AB upon opposite angle sine 115 equals to another measurement is 30 upon sine 9 degrees. So AB would be equals to 30 times sine 115 upon sine 9, and this can be calculated using a calculator, which would be equals to 30 times sine 115 divided by sine 9, which is equals to 173.8. So AB would be equals to 173.8 meters. Moving onwards, we have another turbine, and in case of this turbine the values given are we have 3 different sides given here, and for these 3 different sides we need to find the angle of depression of E from F. Of E from F, that means on point F I need to draw an imaginary horizontal line. So angle of depression of E from F would be this angle. Now this angle cannot be calculated directly because it's not a part of any triangle. So to find angle of depression, first we need to find this angle, right? And I'm naming this angle as beta, or let it be F only for ease, F. So drawing the triangle separately, we can have the figure as like this. And in this figure, this is the point E. We need to find this angle, which is F, and this side is, this point is D. The measurements given is 675, 180, and 130. Now to find F, with the three sides given, we can only apply the cosine rule here. Now cosine rule can be applied as the side opposite to the side opposite to the required angle is 130. So 130 the square equal to 180 square plus 75 square minus 2 times 180 times 75 times cos of f. So this can be calculated with the help of a calculator here. 130 the square minus 180 the square minus 75 the square, giving the value as minus 21125 minus 21125 equals to minus of 2 into 180 into 75, 2 into 180 into 75, which results in 27,000 cos of f. Negative signs would be cancelling each other, and cos f would simply be equals to 21125 upon 27,000, and f would be equals to cos inverse of 21125 upon 27,000, which can be calculated with the help of a calculator as cos inverse of 21125 upon 27,000, which results in 38.5 degree. And the angle of depression would be its complement. So angle of depression would be equals to 90 minus 38.5, which is equals to 51.48 degrees, or that can be rounded off to 51.5 degrees. So this completes our question. In next question, in this question we are using the concept of bearings, and this question has been taken from June 2013, paper 2, question number 6. Now in this question, the conditions what we are having is, we have 4 different points on the level ground: point P, Q, S, and R, and the bearing given for point Q from P is 65. The sides SQ is 335. The side PQ is 500 units. And the bearing of R from Q is 210. In the first part, we need to find the angle PQR. PQR is basically this angle, what we need to find. Now to calculate this angle, if somehow we are able to find this part, so adding up this part and 210 degrees subtracting from 360 would help us in finding this part. Now in my other video which I have made on bearings, you can refer to that video for understanding the concept of bearing in a detailed manner. So whenever we have parallel lines, we have these parallel lines here, and in case of parallel lines we can apply the concept of interior angles. Now interior angles, it means the sum of the two interior angle would be equals to 180 degree. So if this is 65, so its supplement would be this part. So this part as whole would be equals to 180 minus 65, which would be equals to 115 degrees. Right? So this required angle PQR, this now can be calculated using the concept of complete rotation. So angle PQR would be equals to 360 minus this part, which is of 115, minus this part, which is of 210 degrees. So this would be equals to 360 minus 115 minus 210, which is equals to 35 degrees. So required angle to be found PQR equals to 35 degrees. In the next part, we are asked to find the shortest distance. We are asked to find the shortest distance from P to QR. Now to find the shortest distance from P to QR, we have to refer to the main figure. And the shortest distance from P to QR would be this distance. This would be a perpendicular, a 90-degree angle. So whenever the shortest distance questions comes up, always remember a 90-degree angle or a perpendicular has to be formed, means which would result in a right angle triangle. So if this point is X and I have to draw the triangle separately, then a triangle can be drawn in this way. This is point P, this is point X, and this is point Q. The angle PQR we have already found as 35 degrees. So this would be 35 degrees. This is 90. And the side PQ given as 500 units. So simply we can find PX using the trigonometric ratio, and here we can use the trigonometric ratio of sine, because with respect to 35 degree we have to find Px. So sine 35 equals to Px upon 500, and Px would be equals to sine 35 times 500, and that can be calculated with the help of a calculator as 500 times sine 35 equals to 286.78. Px equals to 286.8 meters. In the next part, we have to find the bearing of S from P. Now to find bearing of S from P, we should be having a north on the point P. Here in this figure, you can already see that we have a north on point P. And there has to be a connecting line between S and P. Here we can see that the connecting line is already present between S and P. So the bearing to be calculated would be this angle. Right? Now, this angle or the bearing that needs to be found is not a part of any right angle, is not a part of any triangle. So to find this bearing, first we need to find this angle. Let it be alpha. So subtracting alpha from 65 would give us the required bearing. Now to solve or to find angle alpha, I'm again drawing the triangle separately. Now this triangle drawn separately would be in this manner. this being 90 degree at point Q, this being point S, and this being point P. Now in this figure, the side SQ is 335, the side PQ is 500 units, and we need to find this angle alpha. So with respect to alpha, we are given as a perpendicular and a base. So we would simply be using the tens ratio, and tens ratio would be equals to tan alpha is equals to perpendicular 335 upon base, which is 500. So alpha would be equals to tan inverse of 335 upon 500, and alpha would be equals to tan inverse of 335 upon 500, which is equals to 33.82. And the required bearing to be found would be equals to the difference of 65 and alpha, 33.82. So 65 minus 33.82 would be equals to 31.18 degree. So 031.18 degrees. So this completes the part. Okay, we have completed this whole question. Thanks for watching.